I'd like to thank everyone for joining this afternoon. David, hello. David's our guest speaker from Koppert. How are you?
Good, thanks. Thank you very much.
Very good. David, thanks very much for joining us. I want to thank everyone for tuning in this afternoon as well. It's a really busy time in nurseries at the moment. It's a big time for potting with a lot of the begonias and geraniums starting to come in. So I know people are busy, but I suppose this is reflects the relevance of IPM and mite control. So just a little bit of housekeeping before we go on. And a special thank you to David and Koppert for joining us this afternoon. I want to thank you for the audience for tuning in as well. We have a poll open just to gauge the audience and to see what your experience is. So we'll have a look at that in a minute. We're going to record the webinar, and we're going to have a question and answer session towards the end as well. So please send in your questions and we'll do our best to answer them as we go along. Okay, or actually we'll do that at the end. David, would you prefer that or throughout?
Whatever comes across best. Probably at the end's better rather than trying to break it up. Didn't mind. But I think the end's best time.
Perfect. Okay, thanks very much. So, and we're scheduled to finish at 4 o'clock, so we'll have everyone back out at the potting machines shortly after 4. Okay, so just let's have a look at our poll there and see who's joining us. I don't know, can you see that one there, David, if you click on it? I'll end the poll and I'll share results. Okay, so let's see, we've got a good range of people joining us in from different sectors. So we've got a quarter of people from bedding plants, 38% from pot plants and perennials, 25% from woody, and then 75% covering off other sectors. The question there, are you using IPM methods? And yes is 63%, no is 13%, and don't know or not suitable 25%. Question number 3, if you're using IPM, are you satisfied with your mite control? 13% are not satisfied, 50% are somewhat satisfied, and 50% are satisfied. Those numbers don't really add up, but I suppose it shows that there's a small number who aren't having success with that. And then our last question is, do you have a control mite? It should be a mite control plan that considers the persistence of plant protection products. And yes, 63% and no, 38%. So that's quite interesting that a lot of people are already taking into account the persistence of chemicals. Okay. So that's interesting. I'll relaunch that there if anybody else wants to add into that. So that's great. So David, I'm going to hand over to you, and I'll allow you to share your screen and start your presentation. So I think you've got a PowerPoint presentation, and there are some videos as well that you might narrate as we go along. That's right. That's great. Yeah, I can see that now.
Good.
That's it. And we're into full screen. So I'll just turn off my microphone as we're going along.
No problem. Okay. So welcome everyone. So we're going to talk a little bit today about basically IPM and spider mites. So we're going to look at is different types of spider mite that you might come across on your nursery, and the different predators that will deal with these spider mites. So that's really a nutshell. At the end of the presentation, we'll also discuss how you would integrate chemicals with the biocontrol and which chemicals are suitable and which ones aren't so suitable. So we'll look at that as well. So getting started, have a hand lens like this one. Okay, and you open it up. Go along and put it on your crop someday and have a look and see this site, this horrific site through your hand lens. You'll know you've got an issue with spider mites on the underside of your leaves. So you see a close up here basically of the adults with the 2 spots. So it's called 2-spotted spider mite. The eggs shed skins of the spider mites where they're shedding their skins to grow, and then the damage on the leaves. So let's have a little look just at some of these different pests that you might get. So I'm going to go through 4 spider mite species. The first one is called Panonicus umi. It's the European spider mite, red mite. It's common in orchards. So if you have an apple orchard, you may find this pest. Can be found sometimes on fruit in glass houses, small fruit in glass houses. It's not that common, really. I don't come across it in a protected structure situation very often. So there's really not something about. I'm just covering bases by explaining this is a pest that is in crops, mainly in orchards, I would say. One I would come across occasionally with nursery stock, things like skimmias and so on. You could find this citrus spider mite, so it's basically called the citrus fruit mite. It's also common on, guess what, citrus plants. So if I go to maybe a botanical garden or somebody's conservatory that have a nice lemon tree, there's a good chance I might find this citrus mite on there. It can cause quite a lot of damage, but I say it will go on to things like skimmia. I've seen it on skimmia, and it almost bleaches the leaves. It's quite severe damage with this particular mite. It is quite distinct in how it looks compared to spider mite. It is much bright, dark red. You will see them very easily on the plant. Just to say, it is quite difficult to kill. It's quite resistant. With chemicals, you've got to put a series of chemicals on it to try and kill it. One of the predators I would tend to use for spider mite, called Spidex, Phytocelius, doesn't kill it really. So we have to look at maybe another predator called Neoselius californicus, Spical. Don't worry about the names for now. They'll all be covered in detail as we go on. I would hope you won't find this one, because this one I'm not aware of being in Ireland right now. Let's hope it's not here. So it's Tetranicus evansi. So it's one you'd find in Africa. You might find it in propagators in Africa, for instance. So it can be on Solanaceae. So it'd be anything like the potato, tomato family. Could be on those crops. So it's something to look out for the future. We don't want it, but it could come along with all the importation of plant material these days. The one we're going to focus on for the rest of the talk is basically this particular pest. So Tetranicus urticii. So basically, it's basically 2-spotted spider mite. Some people call it red spider mite. That's the term I don't like using. It's the proper term is 2-spotted spider mite, because it has, as I said, 2 spots on its back. Now, this is common all around the world. I'll just run through this quite quickly because there's a lot of things to talk about. All around the world, major pests, unfortunately, have many glasshouse crops. You can name them all. You're all quite experienced with this. A whole range of plants can get it. This can be a problem right throughout the year. So it just depends on the temperature in the glasshouse. Sometimes I've seen it going 12 months of the year in glasshouses. They've got some heat in them. It never stops. But generally speaking, if you do cool your glasshouse down, they will go into a hibernation stage, which we're going to talk about, and you'll see some pictures of as we go through. Unfortunately, it's got very rapid population growth. It does tend to start locally in an area in a glasshouse. Quite often you'll find a pattern. So I could take you to some glasshouses I know well where the spider mite will start. It tends to start in a corner of the glasshouse. Could be a weed that's persistent that comes in under the foundations of the glasshouse, gets in, maybe like a bramble or wild strawberries, for instance, that get into the glasshouse, and that's where it starts from. It could be living in basically some framework. It does like to live inside even metal framework over the winter. It will live in fans if they're switched off. You'll find it up in the eaves. Quite often you'll see it. We have cucumber growers, for instance. When they take away the plastic, then the spider mite can come down, but the plastic seals it up above the plastic layer. And then when you remove the plastic, then the spider mite makes its way down into the crop. So they're living up high up in the structure, hibernating, and they can hibernate without food, unfortunately. So let's look at the life cycle. So you have the egg, which then becomes what you call this protonymph, which is a very small mite. Okay, there's actually before that. Let's see here. Right. So you have this little larva, which has got 6 legs. Then you have the protonymph. So basically, it's molting all the time. So you see it's really gone from a 6 legs to an 8 legs, then a larger 8 leg with another molting stage. And then you then have the adult male and female. So the male tends to be a bit smaller than the female, and it's sort of thinner at the back here than the female, different body shape. If it gets really bad, you get this webbing occurring, and they're living on the webs. So I don't like to see that in any crop. So they feed on the underside by scratching away the surface, and you get all of this sort of dead tissue area. Then eventually you get the webbing, you get this, but the scratching on the leaves unfortunately causes this reduction in photosynthesis, which is why we don't want it, because you get reduced growth in the plants, and obviously the appearance looks terrible once it gets to a certain point. We talked about the localized thing, but it can also, so thinking about whenever you get spider mite, we're thinking about, has it been imported on the plants or has it come from my glasshouse? Well, one way I would look at to answer that question is when I walk into a glasshouse, is it on a particular batch of plants, or is it in a localized area, or is it so you might have a mixed glasshouse, so it could be on a batch of plants, it could be an individual crop in the whole glasshouse. If it was an individual crop in the whole glasshouse, is there more than one propagator? So can you check different batches from different propagators to suggest that's come in from this propagator or not? Or has it come in from previous crops, or has it come in from your structure? It all depends on the pattern of the spread, how you answer that question. So you're looking for telltale signs, obviously. Is there any logic to how it's got in? One thing I should note, it does like a generative crop, so it doesn't like a soft vegetative crop. Probably realize that a crop that's maybe not growing so vegetatively, or something a little bit of stress, or there's a warm situation or a dry situation, the spider mite will spread more quickly. So some people might try to use one technique. Can you put this overhead water on to sort of keep the leaves wet? Well, that's not something you'd want to do necessarily from a disease management point of view, but I suppose the spider mite wouldn't like that particular environment so much as a dry environment. So here's some typical damage. You can see the mottling on the leaves. So I'm looking for the very first speckles when I'm doing my hand lens checks. Much more subtle than this. You'll see the first few speckles, you're getting spider mite, then you'll look over the leaf, and there will be the first spider mite with a couple of eggs just under that speckle spot. And we talked about the very yellow then as all the photosynthesis, all the tissue's been taken away by the spider mite. You can see here in the webbing. We certainly don't want to see this situation where there's a massive spider mites. So let's have a little look at this population growth. So it takes 10 days at 27 degrees C for an egg to become an adult. Okay, so that's for one generation. A female will lay between 6 and 8 eggs a day. Each female can lay 100 eggs per female. Okay, and development time, as we talked about, does depend on temperature. So warmer, more, up even into the high 30s, they will continue to increase their population growth. Humidity, they want lower humidity. The host plant will have a big part to play. Some plants really do allow the spider mites to grow very fast. Others take a lot longer. For instance, if I was in a tomato glasshouse and I looked at the tomato plant, although you get spider mite, it will take spider mite a lot more slowly than the weed beside it. For instance, the bramble will be covered in spider mite, but the tomato will only have a few spider mites. Just as an example, so it does have host plants where it likes to be on and will go faster. And then we go into this diapause. So this diapause, you get this bright orange, so it changes color. The back becomes tough. It becomes more difficult for predators to eat through the back of the spider mite, and it stops feeding. And then it will tend to either live on the old leaves in the bottom of the plant, or it will leave the plant and go into the structure. So if you have a frame with a hollow tube, for instance, a hollow metal framework, they can go inside the tubing, or if there's a little gap, they can go inside there and live. They can climb up into the fans. They can make their way up into the structure. So really, knowing all of this, then you've got to really think about hygiene and how you clean down your glasshouse in between crops and give yourself a breathing space. You need to have a gap in your cropping to allow you to clean down the surface thoroughly and all the framework. It is dispersed not just by people. So it says clothing and machines, although that's a very common way of spreading it. It can be sprayed, it can quite easily crawl. It can crawl up the framework and then come back down again. It can crawl across benches, it can crawl across floors if it's determined. But one thing people don't normally think about is the air current situation. So it will travel in air currents. So if you have a fan and there's webbing formed on the plant, the webbing gets broken away into little sort of threads, and the spider mites hang onto the threads, almost like sort of a parachute situation, paragliding, where they could actually then just hang onto the webbing, and the webbing will float in the air, and it will take it across the glasshouse to another part of the glasshouse. So that can happen. So it's not just by crawling; it can move on little threads of webbing. Having a little look here, you can see the temperature really does make a difference. So at 15 degrees C, you can see here, egg to adult, 33 days. And there's 80 eggs laid per female. But when you get to 20 degrees C, then you can see there's 120 eggs per female. And the life cycle really goes much faster, 15 days from egg to adult. At 25, it's even faster, 10 days from egg to adult. So temperature has a big effect on how long it takes to make one generation of spider mites. The population is 75% adult, 75% females. So we're going to look at a calculation here. If we know there's 75% females in the population, one female can lay 120 eggs at 20 degrees plus. The question is, how many individuals do you get in 33 days at 20 and 25 degrees C? So let's have a little look at this. We've made an assumption all eggs hatch at one time to make the calculation simple. That's obviously not really realistic. So from one egg, so you can see here at 20 degrees C, 15 days to get from egg to adult, 120 eggs, 75% female. So that's a total population. There's 90 eggs then per adult. So these 90 females then that you get out of the 120 eggs from the 75% population. They also lay 120 eggs because it's 15 days for each generation. So within 33 days, you have this calculation of 10,800 new spider mites from one female originally in 30 days. If you go to 25 degrees C, this figure jumps dramatically. So you can see here 10,800 at 25 degrees C in the same time period. You've got 972,000 spider mites. So the big difference in 5 degrees in the population growth. The good news is we have got predators that are very effective against this pest. Now, this particular, first we're going to look at 3 predators today, and the first predator, and we're going to show a video for it. It doesn't have sounds, well narrated a little bit, but it's still worth watching. So we're going to watch a video shortly about this predator. So you can see it here. It's bright orange in color. This bright orange actually occurs from feeding on the spider mite. Believe it or not, it's not. It actually, without feeding on spider mite, it would be white. But when it feeds on the spider mite, it gives us orange coloration. This is called Phytocelius persimilis. Our brand is Spidex Vital. And this is the very first predator that Koppert started with about 53 years ago. So this is our very first product, and it's still going very strong. There's no resistance to it. Spider mites can't become resistant. Well, they've never in 53 years. So it's the out and out predator. Dónall, do you want to watch this and then come back to the slide if you didn't mind? Watch the video.
Do you want to play it from your side?
I could try. No, the thing is the browser, it doesn't let me come up. I tried that.
Okay. I can cast from my side. Just bear with me for a moment. If you know when.
So I'll talk over. I'll keep talking as you do it. So so it's very. You can see it's a very active pair. So you can see the figures here. 20 eggs or 5 adults per day. So that's his appetite. It is a specialist, so it only likes to feed on spider mite. That's a good point and a bad point. It's a good point because you know when you put it in, it's going to be totally focused on the job. It's a bad point in the fact that if you haven't got spider mite already in the crop, it's going to starve. So it's what you would call a curative rather than a preventative method. Okay, so we're getting an average of 2.4 eggs per day being laid. So it's quite productive in terms of laying eggs. And 53 eggs per female. Any sign of that coming up? There's still trouble.
I will share that now. So
yeah.
Okay, so you should be able to see that now.
Yeah, that's good.
Okay.
So sorry about there's no sound, but I'll explain a few things as we go along. So here you can see the adult Phytocelius, and here's one of just finding a spider mite that's going to touch it to see whether it's something it could eat, and then it decides it's a nice thing to eat. So it's killing several of these every day. You see it basically when it goes into the spider mite, it just then starts sucking the contents out of the spider mite. So it latches onto it. It just then puts its mouth parts into the spider mite. It just sucks the contents dry. Again, you can see spider mite eggs beside them. They will also feed on the spider mite eggs. They are blind, by the way, but they're fantastic at using their other senses. So they will follow a scent trail to find the spider mites. And they're very good at doing that. Here you can see that the egg is sucking the contents of the egg out, so it just completely sucks all the liquid out. It becomes like a deflated ball almost. That's good. Okay, we can end that video. Excellent.
So I'll stop sharing, and you can start sharing again there, David.
I just click on.
I'm not sure. I don't think the sound was coming through on the video there, but
it wasn't
if it was, somebody can drop me a text.
We're back to here. So I think that visualization hopefully told you a lot more than I could tell you on slides. And it's jammed actually, I just noticed. Okay, I need to go back out. Yeah, stop sharing a second. And maybe go back into it, Dónall. That slideshow jammed. Maybe I need to start from scratch there.
Okay, yeah, you can come back out and close down your PowerPoint.
Yeah, give me a second. All right, I'll try it again.
So it's, I suppose, looking at the context of the mites, it is something that most people will be familiar with, but it's striking to see what the level of carryover is from previous crops and from structures. And I guess, everyone's very familiar with the winter cleanup and going in hard with sanitation. But it really does pay off, I guess.
Really makes a difference because these guys are very, very effective at living inside structures. Even hollow tubes, like metal tubes that you'll find quite commonly under benches and so on, they'll be living in there. Here is the I want to show you then.
Okay, you're not sharing yet. No,
I'm not sharing. Okay, let's just quickly the end show. So I'll just share again. I thought I had shared that. Sorry about that. Sure. So you see that now?
Yeah, that's just coming up. Yeah. So
back.
You can go in to make that full screen again.
See that now?
Yeah, I can see it. Yeah, that's perfect.
So here's the different life stages of the Phytocelius. We're looking at the eggs here. They're slightly oval. So if you remember from the previous pictures, the spider mite are round. It would be nice to have them side by side. Unfortunately, it doesn't show side by side, but this is larger than a spider mite egg. So I would say approximately about twice the size of a spider mite egg. Maybe not, thereabouts, at least 1.5 times the size, if not twice the size of a spider mite egg. And it's slightly oval, whereas the spider mite egg is completely round. It's also slightly colored. So when you look at it under daylight, it's like almost like a pink to salmon color egg, whereas the spider mite egg is pure white. So you have the eggs. I'm always looking for the eggs because once I know I can find the Phytocelius eggs, I know we're on the winner because I know they're establishing and I know they will literally outlay the spider mite. They lay eggs faster than spider mites do, so they can actually outdo them. So this, and now the next page down here, the one beside it, the same picture, but just showing this time the larva that's hatched from the egg. See how small it is at the start, and not so orange. So it's only starting to feed on spider mites, so it's still quite clear. It's not quite so, hasn't got the pure orange. Then as you get into the adults, the older the adult, the more molting they go through, the darker they get. So the pure adults are very orange, very easy to see. So you can see the eggs, the nymphs, and the adult in the one page here, and then the adult eating the spider mites. So we've seen this picture before in the video. So you have a 4:1 ratio of male to female. So this is the magic temperature at 27 degrees C. Phytocelius will lay eggs and breed faster and mature faster than spider mite. Above 32 degrees C, unfortunately, Phytocelius stops laying eggs. So it doesn't like very high temperatures. So that's why we're going to talk about some other products. So it really likes to be 20, that 15 plus, but certainly from 20 to 30 is a really nice range for it. Once you get above 32, it doesn't really like it. It likes to hide away from the heat into the canopy of the crop to get away from the heat and cool itself down. So humidity is also a very important thing. So if it gets very dry, it doesn't like it. So you can see here, whenever you have a combination of a high temperature and a low humidity, 27 and 40, you can see that you've only got 7% eggs, adult development, but it's not like that combination of 40% relative humidity with a high temperature. Whenever you've got a high relative humidity of the high temperature, you see it can deal with it quite easily. It's the same figure as the 21 so it's really this combination effect is the problem when you have a low humidity with a high temperature. All right, so to understand that, how do you put this material out? Well, you can do it in different ways. I think the most modern way to use it is using a distribution equipment. So this is what you call a mini air bug. So this is available through our distributor Unichem. So you can purchase these. It's a Koppert built device, and basically you put your product. So it comes as a loose bottle. You pour the product into this rotating drum. These little holes go the whole way around, and at the bottom there's a little down here's a screw. You screw with a screwdriver that comes with the equipment, and you turn the screw, and then the aperture opens and closes depending on what way you turn the screw. So until you get the desired opening size that you want to apply your product, so that then you can get enough product to go out over the crop by timing your walking speed. So you're walking at a speed that allows you to get the product out with the right aperture size. That may sound complicated, but it's not. Operators get the hang of this very quickly just by fiddling around just a little bit and using some instructions we give them. So that's how they do it. The products come in bottles of 2,000 predators and 10,000 predators. So a 100 ml bottle or a 500 ml bottle. They're in a wood chip carrier material, just literally so there's something for them to hold on to as they're crawling through the bottle, and then when you put them out as well. So it's just dry wood chips. So you can either shake the bottle out by hand or you can use this device. I recommend that device if you can use it, because you can spread the material over 2 meters bench width, walking along the bench. So if you walk down the bench path, this material will spread up to 2 meters, either direction. You aim at one direction, you go 2 meters. If you want to go down the far path, you can do another 2 meters. So there's a 4 meter spread between the two pathways you can do using the machine. So it's called a mini air bug. You can check it out on Koppert's website if you want to have a look at it and check out the mini air bug for yourself. So that's what that is. Okay, that's the best way of putting it out. There's a hand application method sometimes used still. All right. So moving on now, I want to talk about a second predator, because obviously we know the weakness in the Spidex. It's an out-and-out predator, which is fantastic for curative. But if you haven't got a food source, then if you put this out too early, the Spidex, the Phytocelius, it will obviously starve to death, and that's no use. So if you want something for preventative, or you want something that's more tolerant of low humidities, or in fact something that's more tolerant of higher temperatures or lower temperatures, then Spical is a product that is worth looking at. We always say to use Spical in combination with Spidex because Spical is a preventative. It's not a curative out and out like Spidex, although it will cure situations if you give it time. It takes longer. But it's a perfect preventative product, and this is why we developed this sachet. So this is what we call Spical Ultimate. So Spical Ultimate is a waterproof sachet, okay, with a hook on it. And this little slit here down this middle, that is where the predators come out of. You don't try to tear it open. People look at and think, where are they coming out of? This one little slit is, we've done all our research, all our continuous tests show that this is what we need to get the product to come out at the right rate. So we're looking for 1,000 predators, sometimes more than that, but at least 1,000 predators per sachet to emerge out of that little hole within a 5 to 6 week period. The way it works is if you hang it up, the first week you're getting some release, but in weeks 2, 3, and 4, you get the maximum number coming out each week. Then 5 and 6 is starting to tail off in terms of release rates. So ideally, you would then replace the sachet within 6 weeks to keep the numbers up if need be. But this predator is quite resilient. It doesn't die within a week. It can live for 2 to 3 weeks without food. It can also feed on pollen in flowers. So if you've got some flowers on your crop, it will feed on the pollen to stay alive. It can also feed on other pests, not just spider mites. It's very happy to feed on nemid mites. The mites that might attack your begonias, for instance, that might make them look more distorted or so on. It attacks those types of mites. So it will search for other food sources rather than just spider mites, pollen, other types of mites, and so on. It is what you call, it is a spider mite. It's not quite a specialist. It does prefer spider mite as its main food source, but it has got that generalist properties to allow it to survive to some extent without having 2-spotted spider mite there. It's okay. Now, it will also feed on, as I mentioned, these other types of mites. So you've got ulmi, which we mentioned on the fruit. You also got the citri. So we'll talk about the citrus mite. We'll also have a go at that. We mentioned about the humidity being low. So if you have a low humidity situation in the middle of your tunnel, for instance, you could use this product instead of the Spidex. We talked about the temperature. I would say plus 13 to 14 would be a safe period, a safe temperature to recommend. So anything above certainly plus 14, it will work very well. It will go into the certainly way above 32. So although Spidex doesn't like 32, Phytocelius doesn't like 32 degrees C, Spical or Neocelis californicus will work for you. Okay. You can also get it as a loose product, by the way. So if you want to get a lot of them released quickly, you can put it out as a 25,000 bottle product, which is this one here. So 25,000 predators in a bottle. Again, it can be put through the mini air bug to apply it if you want to, or you can sprinkle it directly from the bottle. Okay, so let's have a little look at this predator to check in time. So the eggs are a little bit different to the Phytocelius. So this is Neocelis californicus, the life stages. So you've got the eggs, which are not quite as large as the Phytocelius egg, but they are still larger than the spider mite egg. So probably maybe 1.5 times the size of a spider mite egg, something like that. But they are oval, they are clear instead of being that pink color. But so it is more skilled to spot them on the crop than it would be to spot the Phytocelius. But with when you get yourself trained up, you can tell the difference between that and the spider mite egg. So I do look for those eggs to see if they're there and see whether the predator is breeding on the leaf when I'm checking for customers. You can see the larva here. So the larva is not quite the same body shape. It's a different body shape. If you see that, it's more like what I call a pear drop shape, whereas the Phyto is a different shape. The legs are shorter. The coloration, it can be this sort of creamy color, but it does get coloration from feeding on spider mite, where you get some of the contents where you get this brown, sometimes like a brown cross can almost form on his back, where we can see the product inside. We can see the contents of the spider mite has been feeding on. and it just gets larger basically as it becomes an adult. So we looked at this 8 degrees development time. You can see here approximately 30 days. It lives for, so it's quite long lived. Doesn't lay as many eggs per day as the Phyto did, 1.8 per female per day, and an average of 64 eggs per female. But it has got these adaptations, although it's not out and out good a breeder, doesn't multiply so fast. It's got all these other advantages we mentioned: high temperature, low humidity. It's also a bit more resistant, maybe for chemicals, for pesticides, possibly in some instances than the Phytocelius might be, which is useful to know. So here's just an overview of what you're looking at. We should show the video, but I think I'll not show the video for purpose of time because it's very similar to the other video. You see it eating spider mite basically and laying eggs, but it looks like this. So let's just move on to the third predator. So we'll show the video off. Maybe actually what we could do, Dónall, before we do go any further, we could look at one video how to apply the sachets. Would that be possible to do? How to apply the Spical Ultimate sachet. It's only a very short video.
Yeah.
If you want to get that out. So while we're doing that. So where I get the best results, you put this up, I'll just keep talking. The best results are where I have a combination of both predators. So I will have the preventative sachet in place, and then when I see the problem, when I see the very start of the problem, not when I see the problem is too far gone, I will put the Spidex in to try and cure that situation. And when the two are together, they will live side by side on the leaves. I see them side by side. They don't seem to really bother each other too much. They seem to work in combination very well. Never had an issue, and it's recommended they're in combination. If you look on a website, it'll say on the Spical page, always use in combination with Spidex for best results.
Okay, so I have that video up there.
Excellent.
You should be able to see it now.
It's quite a short video, but it gives an explanation. Obviously, you want to open your box in the right way. You need to cut it open, just break the seal. So you have 500 or 100, depending on what box size you buy. So it's either 100 sachets or 500 sachets. They can be then just hooked onto the plant. And in the shady side, I would say, or out of direct sunlight would be the best thing to do. Okay. All right. Good. Simple as that. So that from a labor point of view, it's not too much hassle. They are compostable, but they will take a long time to break down. If you put them in a field situation, for instance, on the ground, they won't break down immediately for you like paper would do. So I would say take care of that if you are putting stuff out on the compost heap. It's probably better to remove the sachet and compost it separately than to expect it to break down in a season. It takes longer than that. So
they are biodegradable, but it takes a while.
It does. It takes a while. You won't have the old paper sachet break down in a few months. That doesn't happen with those. It takes longer. So I say it's better to remove them from the plants and keep them separate than just pile them in the compost heap, because otherwise they'll break down a lot slower than the actual compost, and that becomes an issue. So let's have a look at this.
So you can start sharing again then.
Yeah, I'll share the screen.
Yeah, that's perfect.
Done the same thing. I think I have to restart it. It doesn't like that. Sorry about this. I'll just reopen the PowerPoint that Dónall scrapped. Can I share this now?
We've had a few trial runs to
prepare. It just doesn't seem to be playing ball today. Sure doesn't. It's just getting restarted.
Just can't iron out. Okay. Everyone's used to a few little things coming along as we have our Zoom sessions.
All right, let's just share screen again. I'll also have to go back to where we left off. Apologies about this. So we're just here, weren't we?
So just while David is getting that ready there. Just a reminder as well, if you have any questions, you can add them in there on the Q&A button. We've had a few, 1 or 2 questions in already, but please send them in and we'll deal with them at the end, okay?
Okay, so moving on to the third predator, which we will show another video for, unfortunately, Dónall, so I'll take it to win and out. But this is native to Ireland, so you'll find this coming in naturally quite a lot. I'm always delighted when I find it coming in naturally in crops, so I'll find it in strawberry crops, I'll find it in ornamental crops, I'll find it in cucumber crops coming in quite aggressively and taking over the spider mite population. Not 100% control, but getting certainly a good percentage contribution towards control, having this natural predator. If you want to boost the numbers quickly, and we know it's native, we know it will work, you can release it into the crop, and we're going to talk a little bit about that. So it's called Phytocelius acarsuga, that's the Latin name. Phytocelius is basically what you call a gall midge. So there's lots of gall midges. Some of them are pests. This one's not a pest. This one's not a vegetarian. It's a carnivore in its stage where it's a larva. So we're going to look at this life cycle. So you can see here, we're looking at the adult lays eggs in the spider mite colony, which we'll look at, and then they become larvae here, and which then become pupa on the leaf, and the cycle goes round and round. So let's have a little look at this. So here's the larval stage, and this is the stage that likes to feed on spider mites. So it starts off as a very small larva. It actually starts out really, it's sort of almost like a little orange egg, and the egg is laid in the spider mite colony. And well, it's actually a clear egg in this case, because the orange egg is another gall. But you'll see a little clear egg, and it gets laid beside the spider mite colony. They hatch into a very small larva, which immediately start feeding on spider mite. It just get larger and larger as they eat more spider mites. You see that they're quite ferocious. Each larva will eat 30 spider mites a day, which is quite a lot. A female midge lays 100 eggs, more than 100 eggs. It takes 14 days from egg to the adult. And you can see here, the adults don't live very long, so they want to breed and lay their eggs quite quickly once they become adults. As I mentioned here, it is naturally occurring, so sometimes you get free biocontrol. In another picture, just in more detail of feeding on the spider mite. Here's the egg. So you can see here, okay, what it looks like. Very small, hard to spot the eggs now. That's a very skilled job, actually, to see the eggs. But it's easy to find the larva. It's easy to find the adults. Well, you can find the adults if you look hard enough underneath leaves, or they tend to. What happens is that they're nocturnal. They will fly at dusk. They'll do a lot of. They don't like to come out during the bright sunlight, so they'll hide away under the surface, maybe on the underside of leaves, or even under benching, or just anywhere they can find a little bit darker area, just to sit and wait for it to get darker, and then the adults will come out. That's not so much the case with the larvae. The adults are more nocturnal, but the larvae just keep feeding on the underside of the leaves throughout the day. Okay. If you have a little bit of honeydew, it does help with the adults for them just to feed. That can be helpful if they can find that. Now, the females are very, very good at locating spider mite colonies, so they will scent them out. They will find them, and they will go to them, and they will see how many spider mite are there and decide how many eggs to lay, so that their eggs have the best chance of survival and a food supply. They're what I would call a hotspot treatment. If you know you've got spider mite already, then you can introduce these into the area that the spider mite are. The thing about it is they're very handy to put out, because they come in a tub with 250 pupa, which hatch into adults quickly after delivery. Come in this tub, and you just punch a hole, and you put the tub in the middle of the area where the spider mite are located. We could show the video just to see how that works. It will be quite useful to know. So let's have a little look. There's different rates you can put out. You're not putting a lot of tubs out in an area, really. Maybe a typical rate could be like 1 tub per 1,000 square meters, for instance. It depends on the level of the spider mite population, how many tubs you'll use. Maybe we could show the video of the predator. Is that be possible, Dónall? And then possibly straight after that, the video of how to use it. And then we can keep talking then after that about things. So if you
Spide
go
end.
to,
Yeah,
I go to Spide End Feltiella against spider mite video.
okay.
It'd be very useful just to show it so people can see themselves how it works. So the thing about it is, labor cost point of view, is very easy to put that tub in the area, which you'll see in the video soon. Here's the gall edge, okay.
So they're quite a bit bigger than the mites.
At that stage, but it does take a while to get to that stage. You know, I mean, they grow obviously as they feed. It's that they start out probably even could be even the same size or slightly smaller than the mites, and then they get larger. You can see it just sucking the contents out in front of our eyes.
They're great. Yeah, you'd love to see them coming into crops, all right.
No, it's great to see them when they come in naturally.
Mm-hmm.
So because they're native, I suppose then there's nothing to stop using them in an outdoor situation. You know, technically, because they don't need a license because they're native. But
okay, and you wanted to show the other one then on how to use.
Yeah, it's just so people can see how simple it is to use. And this is the last video then.
Okay. Okay, can you see that?
I can see it, yeah. So you see the double sticky label that it comes with all our products. And it tells you, so you can use that as a marker point on your stanchion post where you put it. All you do is make a hole in the top. It's because it's basically sealed with a terrible seal. So then they hatch out from there. You obviously have to avoid water going in the hole and direct sunlight, so keep them shaded out of direct overhead water. Leave it there for 2 weeks, and then they will all hatch into adults and fly out of that hole you've made in the top. It's as simple as that. And that goes into the area directly that you have the spider mite issue. So I just want to mention, actually, just before talking about the chemicals, very briefly then, the limitations in using these products. So the only one that the main limitation would be the spical, the Californicus. I need to share my screen again. Yeah, I do.
Yeah.
Let's see. It probably won't work. I probably have to close it down. Let's just try. I hope it works. It's jamming again. Yeah. There we go. Should have just closed it down immediately. Oh, it's working now. Oh, all right, so that's good. So if we just go back, so to remind you, this product here, you'll see it's Californicus, the spical product. This one can only be used in protected structures only, just for the licensing point of view, because it's not deemed as native, so therefore you can't put it outside. So just bear that in mind for protected structures only. The Phytocelius, although it's not strictly native speaking, it's been going around for over 50 years. So there's no, it's not the same, but it's been deemed to be around so long that it's still licensed, but it doesn't have the restrictions of the spical from a point of view of use. So therefore that's the case across the UK and Ireland. So that's not restricted. The Californicus is the restricted only. The next one here then, I just need to double check, but I believe it should need a license because it is native, but then I'll just need to double check that. But I haven't used it outside anyway. It's always been in protected structures that I've used it up to now. So looking on now beyond the product, let's have it. This is just an overview then. So comparing the 3 different options, I would tend to say I would usually always use a combination of these first 2, all circumstances, mostly. Sometimes if there's no spider mite, then you could get away with just using this as preventative. But as soon as the first spider mites show up, then we go into using a combination of the 2 products. So you can see one's a specialist, one's a generalist. One can't survive without spotted mite, the other one can. It could be on pollen or other types of pests. One doesn't need a high humidity, one can tolerate a lower humidity. One will develop fast, so that's a good point. This one takes longer, so it's not as aggressive. It's longer to get going. This is a very hybridation rate. This is a medium. So you can see the combination of the two work well. Lifespan's a bit the same. One egg slightly more with the Californicus, but it takes longer to lay the eggs because it takes less eggs per day than the Phyto. So the second generation takes longer to develop than the first generation than it would for the Phyto. So the Phyto can overtake the spider mite quicker than the Neosedius Californicus can. This one here comes into play then whenever you know you've got a hotspot developing, the very first signs of that, and you put in the Feldiella to help you out in the areas where there's more spider mites, specialized, so on. Very easy to put out, as you see with the tub. Looking at IPM strategies, I've got 5 points to think about. So number 5 is the chemical. You see at the bottom, that's the last resort. As far as we're concerned these days, it shouldn't be the first resort, it should be the last resort. We'll explain that. So obviously maintaining a healthy plant is very important. If you have think about below the compost, first of all, if the roots aren't healthy, the plant's going to be not growing properly, then it's going to become prone to spider mite issues. Unhealthy plants will attract spider mites. If the nutrition balance is wrong, if there's too many nitrates in the plant, they can also attract all sorts of pests. So we don't want to have a high nitrate situation in the plant. You can talk to Nova Crop, this company that Koppert work a lot with, looking at sap analysis. So you can get instantaneous results on sap analysis to give you an idea of whether your nitrate balance is wrong. So something to think about, people for the future. So don't always blame the biocontrol. If your sap is wrong, then it's making life hard for the biocontrol in the first place. You understand? So you've got to get your balance right before you say, why is the biocontrol not keeping up with this pest problem? It could be that you're making the balance wrong in the plant and the pest is loving it, and therefore it's hard for the biocontrol to keep up with it. Monitoring is very important. So we talked about crop walks, hand lenses. I use a ×10 for most of my work. We get these out to customers to use as well. We want them to be checking the crops themselves and giving us feedback. You could also use a hand lens you put on your mobile phone. I use that as well, which is very handy. Then you can take videos and send it to myself or Dónall or other advisors you work with to let them see the situation. So that's important. I say if you're not crop walking at least once a week, then things could go wrong very quickly. So you should actually set time aside to crop walk at least once a week. I know that sounds very idealistic, but if you're not doing it, then things can happen and you could get caught out. Cultural control, we talked about some of this. Well, I'm always very suspicious of young plants. I see more often than not that spider mite can come in on young plants. So I would see strawberries, for instance, I would see maybe certainly 25% of the time, or maybe more than that. The propagator gives the spider mite with the plant. I've even seen plants that have come out of being frozen. When they defrost, the spider mite basically becoming active from the plants that were frozen. So even the freezing process doesn't kill off the spider mites. I've watched it happen myself. I've watched the plant defrost and the spider mite come.